Welcome friends. So far we were using forecasting related issues under the analytics, which is a very important area for decision making. We discussed that forecasting is in fact the input for various other plannings which we do in operations management. We discussed that how different types of forecasting methods may use descriptive and predictive analytics. We discussed with the help of time series analysis, with the help of regression analysis, that lot of predictive analytics methods are possible to be used because of different types of characteristics you may have in your historic data. Moving further, another very important area which we discuss in operation management, that is inventory management. We all know when we have a forecast, now we need to plan our entire resources using that forecast into consideration, and for that purpose lot of requirement of raw material is also there. Then we also need to have requirement that okay, this much will be the demand and how many finished goods I should have in my stock, so that I can fulfill that demand of the market. Based on the production capabilities, I also take care that how should I have a minimum level of work in process inventory. So, there are many areas of inventory related decisions in operation management. So, in this particular session, we are going to discuss what is inventory, the role of inventory in operation management, some of the interesting terms like cycle inventory, the cost of inventory, all these things. And very quickly we will also focus on a very common model of inventory management you all know, that is EOQ model. That also we will introduce here, and then the role of analytics come into the picture when we try to understand different types of uncertainties in our external environment. We know that forecasting is just one estimate, but there can be a lot of fluctuations, errors in my forecasting data, and that may lead to some kind of uncertainty in the demand. If I know with 100% confidence that tomorrow there will be a requirement of 100 units, so today I will procure only 100 units so that I can fulfill the demand of 100 tomorrow. But all of you will know from your common sense that it is next to impossible to say that the demand will be of 100 units. It is quite possible that it may be 98 also, or it may go up to 105 also. So, considering all those uncertainties, how should we plan our inventory management? That will be the more important discussion in this particular session. So, with this we start. As I already said that inventory is very much required for fulfilling the requirement of our customers. Now, as I said, there are different types of inventory: finished goods, work in process, and raw material. And you need to keep inventory because there will always be a mismatch of supply and demand. Sometime you have uncertainties in your supply, sometime you have uncertainties in demand, and sometime you have uncertainties in supply as well as in demand also. So, because of all these uncertainties between supply and demand side, because of this mismatch, you need to keep inventory. And now the more important issue is there, that for improving the customer service, we should have more and more inventory. When we are keeping the inventory, the cost is also going up. Cost is up. So, therefore, the requirement is we need to optimize this inventory system in such a manner that you should have a decent level of customer service, and at the same time your cost is also not increasing too much. So, that is a very interesting decision making problem, that what should be the optimal level of inventory which will help you in improving the customer service, and at the same time the cost of keeping the inventory is also not too excessive. Therefore, we have two very important questions for which we are expecting the answer. The question number 1, how much to order? You are going for repeat and repeat orders. There may be some scenarios where you are going only for single order also. But if I consider a business which is a regular business, so you have to order, let us say, every month or every fortnight, every week, maybe whatever frequency you have. So, how much to order? What should be the order quantity? Q. And the second important question is when to order. Should we order on the basis of some quantity label, or we should order on the basis of time interval? You may say that, okay, I am going to order a new lot whenever the present quantity, present stock goes to, let us say, 10 units. I am going to place a new order. I say that I am going to place order after every 15 days. So, we both may have our own policies, that whether we are following a quantity level decision when to order, or I am following a time based interval for deciding when to order. And in both the situations, how much to order is an important question always. Now, as I already explained, there is a significant trade off we have to do, significant optimization we have to do. In earlier scenarios, we used to do this once in a year kind of a situation, but now we are living in the analytics world. Here it is quite possible that we can do it on a regular basis. The important terminologies now let us discuss. Whenever you are placing the order, I will explain with the help of this diagram that when you are having some annual requirement, that is, let us say, R, this is my annual requirement. Now, you are not going to place R orders quantity in a single order. You have divided R into Q quantities, and sigma Q in 1 year equals to R. You are placing some n number of orders in a year. Every time you are placing order of Q quantity, and Q sigma of those Qs equal to R. So, here we are placing the order of Q quantity, as in this illustration is given that Q is, I am considering Q equals to 100. Now, once you give the order, you have received Q supply, and then you start consumption of these Q over a period of time. These Qs are good enough for 10 days, and then again a new supply comes like this, and you are consuming this over a period of time, again 10 days, and then again a new supply comes, and in this way this pattern is going, and this is known as sawtooth pattern. This is known as sawtooth pattern, where you are getting the supply, you are consuming the supply, getting the supply, consuming the supply, getting the supply, consuming the supply, and so on. In this way, every time I am placing the order of Q quantity, that is known as lot size. Now, cycle inventory is actually the half of this lot size. Lot size by 2, Q by 2, that becomes my cycle inventory. Cycle inventory in a way is average inventory that is there, and it is very important for us to know about this cycle inventory, because most of our cost calculations are happening on this cycle inventory basis. So, because this is the average amount of inventory which always you have in your stocks. This is the maximum inventory Q, and this is the 0 label, this is Q, this is 0. So, the average inventory equals to Q plus 0 by 2, that is Q by 2, that is our cycle inventory. So, this is the average inventory which you are always holding in your stocks. So, most of the cost calculations are happening on this average inventory level. Next, we discuss about various costs which we are using in developing this inventory model. Two very important costs are discussed. One is carrying cost, another is ordering cost. Carrying cost is also known as holding cost or maintaining cost. Generally, you are representing it as CH and ordering cost as CP. Maybe in other books you may find a different convention for noting these two types of cost. CH is the cost of holding one unit for 1 year. For example, if I am keeping 1 unit of product in my store for 1 year, I may incur, let us say, rupees 2 for keeping the rent, maybe insurance also, maybe on an average some kind of obsolescence are also possible. The capital which I have blocked in keeping the item, the interest on those capital, that is also taken care in the carrying cost. So, all these things are put together equal to rupees T. But generally the carrying cost is expressed as a percentage of material cost. For example, let us say the material cost of a particular product is 1000, and I say that carrying cost is at the rate of 5% of material cost, then the CH will be 5% of 1000. So, most commonly you will see the expression of CH in terms of percentage of material cost only. The other type of cost is ordering cost, where every time you are placing the order, there will be some kind of administrative expenses, some type of labor, loading, unloading, all those issues will be involved in every order cycle. So, if you, let us say, think in a way that when you are ordering all the items in one go, your ordering cost will be low because only one order, but then your average inventory will increase very high. You can consider two scenario, that if your total requirement is R and you place single order of R quantity, your average inventory will be R by 2, and you have to incur your holding cost for R by 2 label throughout the year. On the other side, it is also possible that you may break this R into single units up to R times. Now, in this case, every time one unit is coming, there is some cost associated with that also, that is ordering cost. So, we are trying to optimize, minimize the total cost, which is sum of CH plus CP. This expression gives you how are we going to calculate the total inventory cost, which is the total ordering cost for the year plus total holding cost for the year. The total ordering cost is number of orders, that is R by Q into CP. R by Q gives you number of orders in a year. And Q by 2 is the average inventory multiplied by cost of carrying the inventory. So, this becomes the total inventory cost, and this is to minimized. And when we do the maxima minima, and we get the expression which is known as EOQ, economic order quantity under root of 2 R Cp upon Ch, a very important expression. Though in our analytics we are going to discuss more advanced things, but this basic model, EOQ model, is the fundamental of entire material management, entire inventory management. So, I request all of you to please keep this EOQ in your mind all the time. However, it is also important to use the values appropriately in this expression, 2 R Cp upon Ch whole under root, because many a time people get confused in writing the values of Cp and Ch. What should be the appropriate value of Cp and Ch, that with the help of examples we will be discussing. Now, one more important thing, if you see the graph on the screen, here you see we have different types of cost. On the x axis we have the lot size, that is Q, and on the y axis we have the cost. Now, here if you see this graph, there is a cost, holding cost, which is Q by 2 into Ch. The formula for holding cost is Q by 2 into Ch. So, as your Q is increasing, holding cost is increasing, and a very clear linear relation is visible. You can see this straight line which is crossing the origin, because if Q is 0, holding cost is also 0. Then another cost is ordering cost, that is R by Q into Cp. As you can see in this formula, Q is in the denominator. So, as the value of Q is increasing, the ordering cost is decreasing, which is also very much evident from this graph which is representing the ordering cost. Now, third is this total cost, which is Q by 2 Ch plus R by Q Cp. Now, if you see this particular graph of total cost, it is very interesting that as your Q is increasing up to a particular level, this total cost is decreasing. It is decreasing, 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 and up to a particular point it has decreased. And then if you start increasing your Q, it is further increasing. So, it is showing a very interesting behavior, and you can see that at a particular level where it is the lowest, where the total cost is lowest, this is actually your Q star or EOQ. One more important thing you can identify, that at EOQ level, at this level, your total ordering cost equals to total holding cost. So, if I use the principles of analytics, simply if I am in a situation, I do not know whether I am giving a right order quantity or not. But if I say that my annual ordering cost and annual holding cost are almost equal, the ordering quantity which I am using in my organization, that is more or less equal to EOQ. There is no need to calculate any other thing. Whatever is your order quantity, using that order quantity, if these two costs are almost equal, you should say that you are operating at the minimum inventory cost. But if these two costs are away, different, then maybe there is a scope of reducing your inventory cost. So, that is a very important managerial takeaway from this particular discussion. At this particular lowest level of Q, the formula for minimum total inventory cost is also available here, that is under root 2 RCP into CH. There are some simple assumptions we use in developing this basic EOQ model, like CP, CH are constant, and the consumption rate R is also constant throughout the year. Now, the challenge is, even though the cost may not be constant throughout the year, but still for the purpose of developing the model, I can assume very easily, conveniently, that these two costs are constant. But consumption rate is a question. Consumption rate, what I am assuming in the beginning of the year, may not remain the same. Even in every cycle, the consumption rate may change. Every cycle, like what I mean to say, that here you see that from this is one cycle, this is another cycle, this was the first cycle. So, in every cycle in this diagram, I am suggesting that one consumption cycle is for 10 days, but it is quite possible that in one cycle these 100 units are able to survive for 11 days, and in another cycle these 100 units are over in 8 days. So, practically there will be variation in the consumption rate also from period to period, but we assume that these are constant over a period of time, and we assume that whatever is my order quantity Q, my supplier is giving the same order quantity every time, and when I am expecting that these orders will come to me, these orders come actually on that very day, there is no delay in the supply also. Now, after these things, there are some very simple things also. One more important terminology, that is lead time. The time when I am placing the order here. If you remember, in the beginning of the class, I said that there are two very important questions. One is when to order and how much to order. How much to order is Q. How much, that is Q. When to order, that is still unanswered. For example, I am placing the order here, this is the point, and I am receiving the supply here. So, the time between placing the order and receiving the supply is known as lead time. So, in our basic EOQ model, we have assumed, just now I told you, that lead time is constant. However, in practical situations it is possible that lead time may not be constant, there may be some variation in the lead time also. So, with the help of this simple example, we can understand that how these situations are developed. We have 1000 units per month requirement. So, the annual requirement becomes 12,000, and we have the cost of different types of CP and CH. CP is the cost of placing the order or the ordering cost. So, that is mentioned 4,000 in this problem. CH is given as 20% of the material cost. So, it is 0.2 into 500. So, these are the values of CP, CH, R is this, and when I use this formula of EOQ, I get EOQ equals to 980, and when EOQ equals to 980, the cycle inventory will be 980 by 2, that is 490, and number of orders per year will be 12,000 divided by 980. So, between 12 to 13 orders you have to place every year, 12 to 13 orders. Now, after understanding these particular issues of a very certain case, but practically speaking, in all our models there will be a lot of fluctuations, a lot of uncertainties. We are not going to work with certain models in our practical lives. So, whenever the uncertainties are there, how analytics can help us in taking care of our uncertainties. Like you see this particular diagram, when the upper part of the diagram, this is the upper part up to this level. This is the same model which I discussed few minutes back. But actually what is happening, because there are uncertainties, I have to keep some cushion with me. If demand is not constant, demand consumption is not constant, it is higher, then to fulfill the requirement of the customer, to remain a customer oriented organization, I should have enough inventories with me, and for that purpose safety stock is created. So, now for me the question is how much to order and how much safety stock to keep also, because safety stock is a kind of a cushion for me for handling the uncertainties. Whenever you have uncertainties, you have to create some kind of a protection for you. So, safety stock is a kind of protection for me. So, now because of the safety stock, my average inventory is going to increase. Earlier, when there is no concept of safety stock, average inventory was equal to cycle inventory. But now because of safety stock, average inventory is cycle inventory plus safety stock. So, my average inventory equals to Q by 2 plus safety stock, and therefore, my cost of holding is also going to increase, because now cost of holding CH for per year will be CH into Q by 2 plus safety stock. So, all of a sudden my cost of keeping the inventory is going up, and therefore, we are going to discuss in detail about the calculations of safety stock itself, that how we are going to handle the issues of the safety stock. You can easily understand the calculations of safety stock will depend how much uncertainties we are going to handle, and if you are having more uncertainty, you need to have a higher safety stock. If uncertainties are less, obviously you will have less safety stock. So, amount of uncertainty is very important. Now, from where the uncertainty will come? In our earlier classes, we discussed descriptive analytics, that whatever historic data you have, you can have two important characteristics. One is measure of central tendency and another is variation. So, this variation is basically the measure of uncertainty of our safety uncertainty in our demand, and that will help us in calculation of safety stock or safety inventory. So, safety stock calculations for us will be based on these 2-3 important aspects. What is the appropriate level of product availability? If let us say demand is 10 and demand can go up to in a period 15. So, every time it may not go up to 15, sometime it may go up to 15 also. So, I keep let us say 13 units. I am okay that sometime if demand is going up to 15, there may be few customers, these customers who are not served product because I may not have that much of inventory. So, there may always be few customers in case of uncertainty who may not be able to get the products from the readily available stocks. So, this is the measure of product availability. Then, if I am ready to have a particular level of product availability, that okay, 90% product availability is okay. For example, so to maintain 90% of product availability, how much safety stock is needed? Because as my product availability will increase, I want to have more product availability, you can easily understand it will increase my requirement of safety stock. And then we also need to see just improving the product availability and then accordingly increasing the safety stock is not the end for us. We also need to see that on one side we should be able to improve the product availability and without increasing the safety stock. That how can we have less uncertainty in our demand data, so that you can offer higher product availability with lower requirement of safety stock. So, all these things are important part of this uncertainty handling in the inventory management. We will continue with some kind of detailed discussions of our safety stock calculations in our subsequent classes. With this, we come to end of this particular class. Thank you very much.